Hello, viewers. In today's session, we are going to discuss one important concept from straight line in two-dimensional geometry. And the concept is how to find out the coordinates of the foot of the perpendicular when we draw a perpendicular from a given point on a given line, right? So here we'll understand and we'll learn this concept with the help of this problem where we have to find the coordinates of the foot of the perpendicular drawn from the point 1 comma minus 2 on the line whose equation is y is equal to 2x plus 1, right? So let us first draw a rough diagram of this problem, and then we'll see how we can easily find out the coordinates of the foot of the perpendicular using the concept of slope of a line, right? So let us start. So here we are given a point 1 comma minus 2. So let us take this point as P, and we are given a line y is equal to 2x plus 1. So let us consider this line as y is equal to 2x plus 1. And from this point P, we drop a perpendicular on this line. Say this line is L, and let us take M as the foot of the perpendicular. So PM is perpendicular to this given line y is equal to 2x plus 1. So here we have 90-degree angle, right? So we can see that here this line, that is PM, is perpendicular to this given line L, whose equation is y is equal to 2x plus 1, right? So let us consider the coordinates of this foot of the perpendicular as alpha comma beta, right? So now we can use the concept of slope here. So here we can see that the slope of this line PM is given by the formula, that is y2 minus y1 over x2 minus x1, right? So this point can be taken as x1 y1, and this point M may be taken as x2 y2. So when we have 2 points on a line whose coordinates are x1 y1 and x2 y2, then the slope of the line is given by y2 minus y1 over x2 minus x1. So here we can now write beta minus minus 2, and then we can write x2 minus x1. So we have alpha minus 1. So this is beta plus 2, and this is alpha minus 1, right? So now let us write the slope of the given line. So slope of the line L is given by 2, right? Because if we compare this equation with this one, that is y is equal to mx plus c, then m is the slope, right? And comparing these two equations, the value of m, that is the slope of the line, is given by 2. Now see, this line PM is perpendicular to this line L. So when two lines are perpendicular, then the product of their slopes is equal to minus 1. So here the slope of PM may be taken as say M1, and slope of the line L may be taken as say M2, right? So here these two lines are perpendicular, so we can use the condition of perpendicularity of two lines. So the product of the slopes is equal to minus 1. So let us substitute the values of m1 and m2 in this equation. So we have beta plus 2 over alpha minus 1, and then we have here m2 is 2, and this is equal to -1. So let us rearrange this equation. So multiplying beta plus 2 by 2, we can now write 2 beta plus 4, and taking alpha minus 1 to the right hand side, multiplying it with -1. So we have minus alpha minus 1. So we have 2 beta plus 4 is equal to minus alpha plus 1, and from here we can write the value of alpha uh, like this, that is minus alpha is equal to 2 beta plus 4 minus 1. So we have minus alpha is 2 beta plus 3, and alpha can be written as minus 2 beta minus 3, right? So this is the relationship between alpha and beta. So now let us call this equation as equation number 1. Now see this point M, which is the foot of the perpendicular, that is PM. This point M, that is alpha comma beta, it lies on the line L, right? So this point M, it satisfies this equation, that is y is equal to 2x plus 1. So let us substitute x is equal to alpha and y is equal to beta in this equation. So we have beta is equal to 2 alpha plus 1. So now we have another equation in alpha and beta. So now we have two linear equations, right? And we can solve these two linear equations by method of substitution. So let us substitute the value of beta in equation number 1, right? So we can now write alpha is equal to minus 2, and beta is given by 2 alpha plus 1, and then we have minus 3. So solving this equation for alpha, we have minus 4 alpha minus 2 minus 3, and taking minus 4 alpha to the left hand side. So alpha plus 4 alpha is equal to minus 2 minus 3. So this is 5 alpha, right? So this is 5 alpha is equal to minus 5. So alpha is minus 5 over 5, that is minus 1. So we have obtained the value of alpha as minus 1. So let us substitute this value of alpha in equation 2 to get the value of beta. So beta is 2 alpha plus 1. So alpha is minus 1. So here we have minus 1 plus 1. So beta is minus 2 plus 1, that is minus 1. So the value of beta is equal to minus 1. So the coordinates of the foot of the perpendicular, which is the point M, are given by M is given by alpha comma beta, and we have just found that alpha is minus 1 and beta is minus 1. So these are the desired coordinates of the foot of the perpendicular. So now let us find out the equation of this perpendicular, that is PM, right? So we have the coordinates of P as 1 comma minus 2, and M is alpha comma beta, that is minus 1 and minus 1, right? So here to get the equation of PM, that is the perpendicular, we can make use of the 2-point form of equation of a straight line, right? And the equation is given by y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1, right? So this is the 2-point form of equation of a straight line. When we know the coordinates of 2 points, lying on the line, right? So this point may be taken as x1 y1, and this point may be taken as x2 y2. So we can now write y minus y1. Y1 is minus 2, and here we have x minus x1. So x1 is 1, and y2 minus y1. So this is y2. So we have minus 1 minus minus 2, and then we have minus 1 minus 1. So this is now y plus 2, and here we have x minus 1, and this is minus 1 plus 2 divided by minus 2, right? And we can further solve it. Y plus 2 over x minus 1, that is 2 minus 1 is 1, and here we have minus 2. Now cross multiplying here, we have minus 2 times y plus 2, then we have 1 times x minus 1. So we have minus 2y minus 4, and then we have x minus 1, right? So now we can rearrange the terms. So taking all the terms to the right hand side, here we have 0. So we have x minus 1 plus 2y plus 4. So we can now write x plus 2y, and 4 minus 1 is plus 3, and this is equal to 0. So this is the required equation of the perpendicular, that is PM. So now let us find out the length of this perpendicular, that is PM. So we have the coordinates of point P and the coordinates of point M, and here we are taking this coordinate as x1 y1 and this coordinate as x2 y2. So by using the distance formula, that is distance between 2 points, we can use this result, that is PM is given by the square root of x2 minus x1 square plus y2 minus y1 square. So we have square root of here we have minus 1, here we have 1, and this is a square, and then we have y2 is minus 1, and y1 is minus 2. So we have minus 2, and here we have the square. So this is square root of minus 2 square, and here we have minus 1 plus 2, because minus times minus is plus. So 2 minus 1 is 1. So we have 1 square. So this is square root of 4 plus 1. So this is square root of 5. So the length of this perpendicular PM is given by square root of 5 units.